Hello, everybody. It's March week 4 for the OSS team, and here's Nate to show us some demo with replicated tables.
It's more than just replicated tables. So this week I implemented ArrowFlight's doGet and doPut methods. The doGet is like a subscription, but it's a snapshot of at the particular point in time, and a doPut is like uploading random data, or not random, but a table of your choice. So I modified my client to create a timetable. It waits a little bit for it to tick, and then it runs a doGet and pipes that into a doPut. So the client doesn't manipulate the data in any way. And then it subscribes to the result table, and then it'll print out both of them. So my client is also running, as Mike mentioned, running the updates through a replicated table to reproduce the table on the client side. So this first one here is the result of the doPut after the snapshot was taken, and that's why it's truncated in a sense, because it didn't keep ticking after that fact. And then this is the result table, or the original table that it was snapshotted from.
All right.
That's my demo.
Cool. All right, next we have Christian to show us some of the demos he's done with performance tracker logging.
Hello, everybody. So I've been working on the binary logs and essentially keeping them on the OSS side, removing the dependencies on the binary logging to disk. This is going to go into an in-memory table. I have a little demo here for one of them, the update performance logger, which is stored by the update performance tracker class that I have here in this window. I'm going to show the output via a unit test, and the unit test actually is going to log on its output, which is not what we normally want. We normally want an actual table, but this particular logger, the update performance tracker, has the option to both log to in-memory table and the log file. So I'm using it for that reason, to be able to show the log file. I've done a little bit of a hacking here, because regularly this takes a configuration for how frequently to log, and it uses a default value of 60. I'm hacking it 60 seconds for a minute. I'm hacking it to do it every 200 millis so that we can see some lines quickly. And also normally for unit tests disable this to not pollute the output, but I'm commenting that out so that we actually see it. So I'm going to run a test that is completely unrelated to this, is the query table natural join test, one of the cases there. Just to show that as the engine rolls and updates get generated, the tracker is actually going to output some data of the performance details of how the query runs for the natural join. So you saw that scrolling down. Apologize for the weird wrapping here. It just ended, so it moved my scroll bar. But this is the update validator table, the aggregation, the natural join, the different stages of the query, and this is the data that this thing typically produces. So that's it.
All right, very cool. All right, next we have Jiangfeng showing us some of the work he's done with Python to get Python working.
Okay, everyone. So this week, with Devin and Colin's help, I managed to get the Python console partially working. I'm going to demo it. And you can run very simple Python command on this console, but I haven't tried to actually use any data on the server side, the Deephaven data. I'm sure that if I tried it, it would probably fail. So I don't know what's the next step for me, but that's the demo for this week.
You should show importing Deephaven.
Oh, okay, yeah, okay.
All right.
Yeah, that works.
All right, cool, very cool, very good. Next, we've got Devin to show off some of his work with adding optional packages to classpath.
Okay. So here I'm showing a simple way to add extensions to the Deephaven class path. from a script session perspective. Here we've got an initialization script that is adding a third-party library called ClassGraph right here. And as part of the script startup, I'm going to be inspecting some different files that are part of our class path. And this is potentially useful for developers who are debugging, but it's not, part of the normal Deephaven deployment. So we can go ahead and run our client here. You'll see our script just executed, and it's giving us a little bit of helpful information here. And we can go ahead and we got to go. Sorry.
Show, right? Yeah.
Table, yep. So this is a table. We can see, every class that's on our class path. We could, show JSON table. I mean, since these are classes, we can, just query them like normal stuff here. So we want to find all the schemes that are not a jar. And it turns out we've got one file that is a class that is not in a jar on this class path. I don't think I have too much else to say about that. But yeah, this is kind of a way to add extensions and third-party custom code in kind of an easy way.
All right, very cool. All right, next up we've got me working to show some hooking up the web UI with the Groovy session and also command history being persisted locally. So I've got my stack already running. This is running completely locally, and I can run commands like right here. I'm creating a table with 1 billion rows, and it has sine and cosine, so you can actually scroll through the whole table now and go right to the bottom. You see there's 1 billion, row billion, so that's cool. And then also the command history is persisted locally, so I can go up through it and I can search it, and that's all working now. And if I refresh, then it should load back up. Yep, there we go. And that's all stored locally. All right, and that's all we've got for this week. So take it easy. Bye.